Okay, am I streaming? Okay, am I streaming? Okay. The reason why this is sudden is because I was watching another debunker, a guy named Craig. And Craig is a military veteran, and he is in pain. He I think that what happened is he injured his arm, then went jogging years ago or on a marathon and tore up his knee, and he's been trying to get his leg amputated pretty much ever since, and that's been longer than about 15 years ago, he says. He used to be a nuclear engineer in a nuclear submarine. So okay, we're going into Flatzoid land. Flatzoid is a debunker from South Africa. He earlier.
What do you believe?
He earlier said today he wasn't going to talk about any more flat Earth stuff, and he's leaving the flat Earth community. Apparently, some of them have been grouchy at him, or calling him a liar, or don't know what he's talking about, or worst yet, in their view, a Mason. So, but I was going to do a video about this conversation he had last Thursday morning.
With the expert reviews, price badges, and most cars in Canada, the answer is Auto Trader.
Nobody yet. Okay, we're going to skip through his intro. Okay, this is Luca or Lucas. I think he's the token globe earther on this in this forum.
And then on Saturday, it's me versus Cupcake on biblical cosmology. So it's going to be quite interesting. Yeah.
Alright.
Looking forward to that. So why do you wake up so early, man?
I don't know.
You can sleep?
I don't remember last time when I joined, not the previous stream. I don't think. I think it was the 2 streams ago.
He sounds a little bit like a guy from a guy that I heard from Uruguay, but I don't know if that's the accent or just something in their voice boxes. So we'll just let it go.
I joined and I fell asleep.
Okay.
I woke up and I saw the live stream box and everyone was gone. I slept through it. Oh well.
Okay, I'm just going to skip ahead here or speed it up.
So, is there anything specific you want to challenge me on?
There's playback speed right there.
Maybe that video you did about Sam and Dan.
Oh, the one that was today.
Yeah.
Why things fall. Yeah. What about it?
Okay, so you don't agree with gravity, so why do things fall then?
Because nothing can support it. If I lift something up, you would agree it took energy to lift this phone up.
Yeah. Okay.
And when I let it go, that potential energy has to turn to kinetic energy.
Well, on our
No, in reality.
In the globe reality.
No, not globe in reality. No,
but on our.
You guys say gravity.
Yeah, gravitational.
Well, the thing is, it's muscle energy that you're using to hold it up, not kinetic energy. When you pick it up and then drop it, the potential energy if you have something up here and you're going to release it, the energy that you lifted it up and it gained becomes into kinetic energy, and it wants to go down to zero potential energy. That's what's happening. And if they go into this discussion for a while, we'll let it go through for a few minutes and see how it goes.
No potential energy, right?
But remember, you just asked me, according to me.
Yes, according to you. What say you? Yes.
I pick it up, I put energy to the system, so therefore it has now its potential to turn into kinetic energy.
It has some kind of potential energy, yeah.
Yeah, potential energy is just potential to move. That's it.
Yeah.
And if you know, because the phone will be denser than the air around it, nothing can support it. Where does it have to go?
Okay, their theory is that density is what pushes things up, what is what's working. So if you have a more dense substance, the thing is a more dense substance has more mass. Therefore, it's attracted to the surface to the center of the Earth more. That's why dense things are closer to the ground. But they think it's density's what the force that's behind everything. But if you look at a density or buoyancy equation, gravity's included. So they don't know what they're talking about, but they think they know what they're talking about. Sorry, got something in my throat.
Down, it has to turn to kinetic energy and goes down. Simple as that.
So why down?
Why not? That's where I picked it up from. Took energy to pick it up, correct?
Yeah.
And what's supporting it at the moment is my hand holding it. The air is not able to support it, correct?
Uh-huh.
So what happens when you let it go? The potential energy turns to kinetic energy. Now let's take the same phone and let's stick it in mercury. Will it float?
It will, yeah.
Because mercury can support it.
It's denser than the fan.
Because it can support it, exactly. Now if I remove the mercury and now it's just air, what's going to happen?
It'll fall because of gravity. But
Not gravity.
You don't
No
believe
gravity.
gravity. So what's
No, there's
making
no
it fall?
gravity there. Nothing I
Yes,
just
so what's making it fall is
explained.
not gravity.
Nothing I just explained required gravity.
Yeah, but what is making it fall if it's not gravity? We say gravity is the reason things fall, right? So what's making it fall if it's not gravity?
I just
Well,
told
what's the
you.
force, right?
I just told you.
But there needs to be a force, right?
Yeah, the force is simply the object having an unequal balance between the medium around it. So the ratio is different.
And Luca, you're also assuming gravity is taking place in an environment you can't prove exists.
Mm-hmm.
Well, I didn't say anything about space.
Well, right. No, but gravity is based on that.
Anyway, it's good to see you, Derek. Good to see you, Anush. What's
Hello.
going on?
Hello, I didn't want to interrupt.
GLA.
Okay, they're going to start talk. There's two ways of viewing gravity. There's the mass attracts mass, and there's also the curvature of space-time. Let's see if I can find a quick image. Okay. Okay, hopefully you're able to see this. Yep, you're able to see it. More dense object, more massive objects, geez, they got me saying that, bend space-time. Space-time is, well, space and time. This is where the theory of general relativity comes from, or is based off of. And you can, let's see if okay. Okay, it's going to be like that. But you can see here that the Earth has a big curvature in space-time. That's relative to us. We have little tiny curvatures in space-time. And since we want to take the route of least resistance, we'll go to into the gravity well of the Earth and get as close to the radius as we can. Well, unfortunately, we have rock underneath of us that prevents that, or a house behind underneath of us to prevent that. But the thing is, the equations that equate space and time, or make the space-time curvature, eventually comes out to mass attracting mass. So it's the same thing. It's just a different form of the same equation. So, okay, back to them.
Right. What's GLA stand for?
Greetings, Luca.
What's GLA stand for? Wait, is that like
God-loving
your
anarchist.
initials?
God-loving anarchist.
Oh, gotcha.
Yes. And further description, no NPCs and placeholders.
Alright. So on Saturday it's going to be the UN Cupcake, right? Or is that
Yeah, cupcake. Yeah.
Saturday? Okay, gotcha. Nice. Yeah, very good.
It's going to be exciting because it's biblical, and I love doing biblical debates, especially biblical cosmology. So it's going to be fun.
Oh my.
What's up, Roger?
Not that much. How you gentlemen doing today?
You did. So I got a question for Luca on gravity.
Welcome, Roger. And welcome
You
to
claim,
Grandmother.
you claim
No,
gravity.
Sorry.
You claim gravity causes the phone to fall, correct?
Mhm.
But gravity is not seen as a force. So how does what is causing the phone to fall?
what?
If gravity is not a force, because you agree you require force for things to accelerate.
Start your engines and
Oops. Okay, how do I share this? again. Okay, I guess I can't while I'm in the stream. Okay, I'll go back to them and let this ad go
Shot
through.
of that chrome because the Maritime's ultimate classic car experience is rolling into town, baby.
It's Fred Ride 2025, happening August 8th, 9th, and 10th in historic downtown Fredericton, New Brunswick. Over
you and me.
400 vintage, classic, and specialty cars on display. Food trucks, vendors, and an outdoor screening of American Graffiti on Friday night. General admission tickets are $15. For more...
And since gravity's not a force, how is it causing acceleration?
You know what?
That ad's not for
Locally,
me, so.
Sure, it's a force. Why not?
No, but that, you can't add locally a force. It's either force or it's not.
Yeah, it can be considered locally a force. So yes, it's a force.
So
in everyday life, it's a force.
but globally it's not a force.
In reality, it's not a force, but locally, it can be treated as a force. Why not?
You cannot have cake and eat the cake. You cannot
Why
be
can't you
force
treat
and
it like
not
a force?
force.
It does the exact same thing as a force does.
This goes back to this curvature of space and time. I don't know the technical details, but since it's the curvature is causing you wanting to go to the center, and that effect that makes it not a force, but you can treat it as a force. Most university, like up until a certain level of detail, or when you deal with certain masses, you deal with it as a force. So
So why
You
can't you
cannot be
treat it
at
like
the same time both things. You cannot be free
you
slide.
can observe it doing the same thing a force does. So why can't you treat it as a force? Locally, that is. So in everyday life, you
Because
can
it's not,
say it's a force.
because it's not a force, and what's the meaning? Because we have to be
In
exact.
everyday life, if you ask an ordinary person,
oops, sorry.
like a person you see every day, is gravity a force? Likely they'll say yes.
But does that make it a force, though? Just because they say so?
You can treat it like a force. You observe it doing the same thing as a force does, so why not? You can treat it
Well,
like a force.
Luca, you would agree you're a mammal, correct?
Hmm?
You agree you're a mammal.
Yeah.
Can I treat you as a dolphin?
Eggs are born alive. Babies are born
Can I treat you as a
alive.
dolphin?
I think that's a criteria for a mammal, right?
A dolphin is a mammal. And it's just, most of the hair is gone because it's adapted to sea life. So a dolphin is not a fish. It's a mammal. So if you're saying you're a mammal and can I treat you as a dolphin? Sure. Dolphins are mammals.
The babies are born alive?
That's the point. The point I'm trying to make is you would agree that a dolphin is a mammal.
Yeah.
And you're a mammal.
Wait. Yeah, dolphin. I think I'm...
You think it would
yeah,
be fair
yeah.
to treat you like a dolphin?
Well, no.
So why are you trying to treat gravity as a force when it's not a force?
Because it does the exact same thing as a force would do. So why can't you treat it like a
Because all
force?
people's MA says there has
It does the same thing as a force, so it's a force. Or you can treat it as a force, so.
to be a force present.
Yes.
And
Okay.
if gravity's not a force, it's not the force present to cause
But like-
acceleration, therefore it's not gravity.
But like it does the exact same thing as a force, though. So it observably,
It's a contradiction.
it observably locally on Earth does the same thing as a force does. So you can treat it as a force.
So can we then
In
say
everyday
it's not
life.
gravity then? Could it be something else?
Could there be another force that isn't gravity? We haven't at all detected anything else other
Okay,
than
think what it could be. Use
Gravity.
your intelligence and think what it could be. If not gravity.
If gravity isn't the reason things fall to the ground at 9 meters per second squared, it is because, I can only think of one other reason, that Earth itself is accelerating up at 9 meters per second squared.
No,
But
that's
that-
the thing.
But the problem with that is though, because you have a globe, which side of the globe is going up?
Yeah, that's true. Yes, that's
Okay.
true. Because if it was the other side of the globe, then it would not act
If
the same
Earth is
way.
accelerating-
Yes, it would be different on the other side of the globe, if that was the case.
Can
It
you
can't be.
agree that to accelerate some kind of object, you have to provide energy?
Yeah, we
Alright.
wouldn't even know where to
Okay.
begin with what is accelerating it upward in the first place.
Alright, so from where this energy comes from, which causes Earth to accelerate?
Yeah.
Earth has not accelerated. Well, here's the thing. You have an effect on the Earth, and the Earth has an effect on you. But the thing is the effect that you have on the Earth is so small, it doesn't really matter. Plus, there's somebody on the other side of the Earth that's probably got almost the same mass, and it's kind of canceling it out. So it's not. So you don't have to worry about it. There is something in general relativity called the equivalence principle. If you accelerate something like at 1g, and you have something with a gravitational field at 1g, like a planet, you could not tell the difference between the two because it would have the same effect on you. But that's not what they're talking. That's what they're trying to get into. They're just trying to say the Earth comes up instead of you're attracted to the Earth.
Well, yeah, obviously you can't. So, yes, Earth does not accelerate upwards at 9 meters per second squared, so we're left with just one, which is, well, gravity. So, I can't think of
Force.
anything other than gravity that could cause that 9 point meters per second
Gravity
squared.
is not a force, and even if we treat it as a force, it still doesn't make a change. That is not a force. So from where this energy comes from to cause acceleration?
You can what? No, I just said it's impossible. So no, you can't be accelerating upwards. Because then it would be different from the people on the other side of the globe if it's not gravity. There has to be a force acting on all directions for it to be a globe, which aligns perfectly with what gravity says, actually.
So from where this energy comes from?
Like what's the reason? Like why does mass
No, not the reason.
cause
From
gravity?
where this energy comes from?
Like why does mass cause gravity? You mean?
No. From where does this energy come from? It has to come from outside source, yes?
I guess it comes from gravity.
It's circular reasoning, gravity, because energy comes from gravity. We cannot do that.
Okay, then what should I say? I don't know how to answer that question.
That's why I'm showing you. It's circular reasoning.
So that's why I'm asking you. That's why I'm asking you the mass thing. Like I'm asking what makes mass cause gravity in the first place. Like what makes mass attract mass in the first
Mass
place.
doesn't affect mass. You have buoyancy and different density of the objects.
Yeah, buoyancy, density, and mass.
Okay, you do have the curvature of space-time. There's other theories of why there's gravity. There's quantum theories of gravity. There's things that rely on string theory, which is, I think I've explained this about a dozen times in the last 2 weeks. But everything has like a string, like every particle is a string, and you change the vibration of these strings to change things like mass or electric charge and stuff. There's also quantum loop gravity, there's this field of particle called gravitons that have a certain spin to them, and they cause gravity. There's also the Higgs boson, which is a particle that causes everything to have inertia within the field that this particle emits, and they're called the Higgs field. That's why we have the LHC. That's what they were built to find, and now they're trying to build a bigger particle accelerator so they can pump out the Higgs bosons to figure out the parameters of the Higgs boson. But the thing is what transmits the energy between the two, nobody knows. Like in electricity, between an electron and a proton, they create what's called a virtual photon, and it transmits the energy or information about the energy between the proton and the electron, or electron and electron, or proton and proton. Oh my god, I'm gonna get this all messed up. I get the weak and the strong force mixed up. But they have bosons, which are force carrying particles. I think the weak has the W plus and Z minus. And the strong, which keeps the quarks inside of the particle, inside of the atom together, have what are called gluons. And I probably botched the last two up. So
Mass attract mass can exist all at the same time. But why does buoyancy stop mass attracting mass? You know?
It's a false equivalent.
Guys, look at this. Acceleration in physics does not necessarily imply movement. What is acceleration in physics, Lucas?
It's standing still, flat.
I don't know what that means, and we'll let it go.
It requires movement.
And I'm laughing in the back.
Acceleration is the change in velocity over time, but you can also, the thing is with velocity, it's also a vector, and acceleration's a vector. It has, if you're doing Cartesian or rectangular coordinates, it has an x component and a y component. And if you're doing rotational, that's like something spinning like the Earth. You change direction, but you can keep the same velocity. So that's how you can have acceleration with no velocity change.
Background, but I am self-muted.
Oh my word. Thank you for the laugh of the night.
Hey, look, I think Flash is trying to say that the energy you put into anything is transferred. That's what he's trying to get to. It's not necessarily a downward bias. But there's energy transfers and things that do rise up too. Like water vapor, for instance.
Well, the thing is, we always get, why don't things, when you pick it up, why is it not falling up? Simple, because you have to put energy into the system. You took energy to pick it up. Why would you expect it to use more energy to go up further?
That's why implementation of guardrails is so important. I don't care what's...
Yeah, where would it go?
How about this?
Because you're moving it from... Because if you're moving something... You're moving something like up to here, and then up to here, you're moving it from here to here, which takes energy.
uses the same amount of energy to move up, and then it just stops.
Why?
It hovers in midair
Why would it hover in midair?
because you applied energy into it. So it
Yeah, but
uses
energy
that same amount
needs
of
to,
energy
according to the first
go
law,
up.
it needs to transfer or transform, and that
It
potential energy has
transforms
transformed into kinetic energy.
It transforms into kinetic energy going up.
No,
Yeah.
why would it go up? It took energy to
Because-
pick it up.
because you were
I
pumped.
literally had to use energy to pick it up, Luca. Why would it carry on going up? That means it has to have more energy to go up.
No, it goes up and then it stops. The
Remember,
same
no,
amount.
Okay, why it stops? Why it
remember,
stops?
remember when I explained the medium? Okay, the medium can't support this phone. The air around it. It can't support it.
It can't
It's the
support
same.
it
It's the same when you
everywhere.
take. It's the same when you take a basketball and you try and force it down into a pool.
But, like,
You have to push it
air
down.
can't support it on all directions.
No, of
Right.
course air can't support in all directions. Air is not
Yeah.
dense enough to
So
support it
why does it go down then?
because it can't support it. I
Yes,
picked it
can't
up.
support it upwards too, or sideways.
I used energy to pick it up.
Uh-huh.
When I let it go, why would you think it needs to go more up if you have to put more energy to make it go up, Luca?
Well, who says it needs? Who says it can't use the energy you imparted on it to go up some more?
Yes, if you add more energy to it, for example, Flat will lift his hand higher, he will use more energy. It will go higher, that's true.
So you
When
lift
he
it up
stops,
and
and he will let it go, then we let
Then
it
you
go,
let it go,
the
and
medium cannot support it.
it uses Flatzoid's imparted energy to move up the same distance he lifted it up till.
Because it's got to do with the medium, the object to medium ratio. What happens when you try and take a basketball and try and force it down in a swimming pool? You have to push it down now
Yeah.
because the force from the water is trying to force it up, correct?
Mm-hmm.
Because it's denser.
Well, I'd say buoyancy, but
Yeah,
Yeah.
buoyancy is
it's not
based on density.
just because it's denser. Well, yeah, okay. I suppose. Yeah.
So I push it down, and the force from the water, if I let it go, forces it back up. That's the same way if this phone is now, or the basketball, we'll say it's a basketball, in air, I have to force it up now. And it can't support it, so the potential energy turns to kinetic energy and uses that energy up.
So you say, well, your explanation for other than gravitational energy is kinetic energy.
Kinetic energy is the use of the potential energy. It's just transferring
Okay.
energy.
The use of the potential energy is not gravitational potential energy. It's
No
kinetic
gravity
energy.
needed.
So what we say is gravitational.
Technically, what he's doing is using muscular energy to move the object, not kinetic energy. And then when the potential energy is up here and he lets go, it turns into kinetic energy.
Potential energy. What you say is kinetic energy.
No.
Right? No.
Potential energy, just not gravity. The potential energy comes from the medium to the object to medium ratio. If it's able to support it, it will support it. If it can't, it has to go back to its relative equilibrium.
Well, then why would it have potential energy in the first place?
Because I picked it up and it's literally I had to force it out of its relative equilibrium.
That
I had to
give
force it.
potential energy.
Listen, I had to force it up. I used energy. Now that is a potential to become kinetic energy. If I had to pick it up and now stick it on, like I said, in a bucket of mercury, let's say this is just a bucket of mercury. Now if I pick it up and I stick it on mercury and I support it, do you understand the mercury has enough force to keep it at its relative equilibrium?
Because mercury is very dense, right? That's why, for
I
example, in the
wouldn't
video,
say force. I'd say dense.
That is a force. The force is
What?
resistance.
Density is not a force. How
It's-
dense something is not really a force. No. You can like.
Would you agree
Like-
that this phone has a force exerted on the air around it?
I
It's exerting
suppose,
force.
because well, when you let go, there's a force imparted on the air molecules. as
Based on
opposed
because
to
of the
space.
phone, correct?
Yeah, like every piece of air molecule would have a force imparted on it, and it would just move away real quick.
Yeah, because it can't support it.
Yeah,
The
it's
force
like,
of this
it's like
phone,
when
the force of the phone is more than what's able to be counteracted
it's
by
like
the
it's
medium.
like when you drop a rock in water. The water just separates as the water goes down. Same thing happens with the air with a phone. The air moves away, and the
So it
phone
can't support it. Yes, because the force is not enough to be able to support it.
Well,
This is like real life demonstration of general relativity, just not in space.
You haven't really. You said what we basically say though.
No.
The air can't support it, and it falls.
The problem
The
is
only
you guys are saying,
difference is
you guys are saying,
gravity
wait,
with kinetic energy.
wait, we have the same observed phenomena. The difference is you guys claim a magical fairy gravity that you don't know what it is, when we can literally tell you what the cause is and literally prove it by doing demonstration.
Hey, Flats, Eric DeBay made a video recently about this. It's really good. Right?
Yeah,
But if you want to get it, you can watch it. It's really helpful.
Okay, and they're talking about, they're starting to talk about another flat earther. But the reason why denser things are closer to the Earth is because of gravity. The buoyancy does not cause the force. It's the force causing buoyancy. And Eric DeBay is another flat earther. There's several flat earthers are in several different camps. There's the Flatzoid camp, which he says he's not going to do flat Earth anymore. It's all going to be biblical cosmology. He said that earlier today, and he was already talking about it within the same live stream. There's the DeBay camp, which has the 200 proofs. He's the one that does that. There's the David Weiss camp kind of thing, and and right now they're all, and then there's Witzett's group, but right now they're kind of fighting amongst themselves because last December there was that the final experiment, the trip to Antarctica. So they're all fighting over trying to figure out how the 24-hour sun can work on a flat Earth, and so all these little camps are just and then there's like a TikTok camp, or there's all these little different little groups are fighting amongst themselves, and they can't stand one. Some of them can't stand one another.
Help explain the therefore of gravity and how it does work. I thought it might be a tutorial. It's good help. Not to say that you can't explain it. Eric does a real good job breaking down the math, and he uses like physical objects in the real world.
Flat, here's the link. Please hear the link. It's 10 minutes video.
So, I just can't see, like... Okay, we'll watch this.
So-called
Yeah, let's watch it again.
law of gravity is a monumental hoax and constitutes one of the biggest psyops in all of history. Assuming we actually live on the spinning globe Earth promoted by modern Freemasonic science, consider the following calculations and contradictions. The supposed law of gravity claims its mysterious action at a distance force can be measured as g times m1 times m2 over r squared, with g being equivalent to 6.674 times 10 to the power of minus 11. Now, consider the One World Trade Center in New York, which has a mass of approximately 1,050,000,000 kilograms. This means that if you are an 80-kilogram man standing 10 meters away from the One World Trade Center, then there should be an expected horizontal gravity of 0.05606 meters per second squared.
He said it.
Yeah, but the thing is they'll point it out later, is that the gravity of the Earth is a lot more. The mass of the Earth is 5.94 times 10 to the 24 kilograms. So, compared to a building that's several thousand tons, it's not much. So, like a ton is about 10 to the 3 kilograms, so yeah, so it's a lot more. So there's 10 to the 21 more kilograms in the Earth than there are in that one building.
Just have to point out Dubai's actually wrong there, because the Earth's mass would be more, so it would cancel out. So it'll cancel out that horizontal.
And it's the thing is since space-time is curved and something comes within the curvature of the object, the curvature is already there. So once the object comes within that curvature, it feels the effect of the gravity of the planet.
Oh wow, you're defending us.
I'm just correcting Dubai.
Yeah, there's a point to it though. It's about the horizontal, the gravitational pull. He'll actually.
Yes, I'd say that the horizontal gravitational force would not be enough.
Even if you would go with the globe planes, in this case he's correct, because there will be gravitational pull down and the gravitational pull horizontal, the building.
It probably would affect air, but it wouldn't affect people or anything else, really. Because
well,
air
if so science claims it does, because mass attacks mass.
Well, yes, but
so you contradict yourself because you believe in it, but it didn't work. So which is it?
But it's not a big enough mass. It's not big enough mass to noticeably affect.
That's what I'm trying to say. The mass isn't large enough compared to what the Earth is in their belief system. So that's why I said Dubai's actually wrong. The thing is, Dubai could be right if he kind of worded it differently and place it almost like the Cavendish, where it requires torsion. It requires torsion to move it based on the belief that the counteractive.
I don't know what Dubay is trying to prove here with this picture, but I'm going to point out something. You have the force of gravity coming down through the ball or whatever this is on the string, but there's also another force coming up in tension, equal and opposite forces.
Force of gravity is pushing it towards the building. Then it would be fine. But the way he made the argument was wrong.
But he can kind of break it down a little bit better. He gets to the macro, like the small, minute force you would actually get from a mass that large. So I think he doesn't average it out with the gravity of the Earth. I don't know.
I know you guys are seeing this, but
I'm still on about what you eat. I'm still thinking about what you laughed about earlier when the guy said acceleration doesn't mean movement.
Because you know what acceleration is.
Acceleration is like the weight at, basically what the weight at which an object's velocity changes
over time.
Oops.
Yes. So if something's just standing still, is the rate of velocity changing over time?
Doesn't.
No. So there's no acceleration.
It
has to do with motion.
If you
now you get it.
toss a ball straight up,
seriously, you cannot not get it. What you're talking about.
If you toss a ball straight up, at the moment it starts coming back down, the velocity is 0. Right?
No.
It isn't moving up or down in that
When
instant.
it's 0, that means it's stationary. That's not accelerating. It then begins to accelerate as it falls down again. Okay.
But during that instant, the ball has acceleration without moving.
No, it doesn't. If it's zero motion, there's no acceleration.
Take charge of your health with the #1 doctor-recommended multivitamin. Up top, Centrum. You did it!
The Collingsworth family is coming to Sussex, New Brunswick. Get tickets today and don't miss this night of music and inspiration.
Okay, look, you are in the car. You are sitting in the parking lot. Not moving your car. Not pushing gas. Are you accelerating?
Well, that's not what. That's the necessarily movement. But I'm saying not necessarily. Acceleration doesn't equal movement necessarily.
Oh Jesus! Okay,
Because,
no, skip it. I can't listen to it.
Like movement is non-zero velocity, right?
Okay, I need to go.
But another one from Phil. Are you sure you're using a force to hold it up? Is that force not? Is your hand not at rest? No, I'm using force to hold it up. You know how I know? If I stand long enough like this, my hand's gonna get tired and I will have to let go eventually. I'm literally having a force to keep up this phone. What the hell? Oh my word, Phil. I think you're trying too hard, man. I think you're trying too hard.
Well, hasn't it been over a year now since Phil wasn't able to come back at you with that previous argument?
Yeah, still waiting for that. It's been, what, a year and a half already?
It's been some time now. And either he abandoned it or...
He's hoping everybody just forget about it.
If the speed and direction stay constant, like...
That's not an acceleration, is it? What you're saying?
No,
constant is not acceleration.
Movement, but... Yes, that is zero acceleration, but it is movement.
No, acceleration requires the movement, because acceleration is the amount of movement about over time.
It's just the way at which an object's velocity changes.
Yeah, and if the velocity doesn't change, what's velocity?
It's a vector, like it's a arrow, right? It's which direction it goes.
The rate of change.
Yeah.
So you can't have acceleration without velocity.
No, right. I still think that it's like non-zero velocity can exist with zero acceleration.
Zero acceleration, there is no such, that's an oxymoron. There's no such thing as zero acceleration. It either accelerates or it doesn't.
Well, what about that ball? Like if you throw a ball up in the air, at the moment it stops moving, that's zero acceleration.
It stopped moving, it's not accelerating anymore.
Yeah, that's zero acceleration.
There's no velocity.
Yeah,
but look at your
it's not accelerating. But
okay, let's do it this way.
Okay, I'm going to skip ahead here. There's one part that I really wanted to go through. I've seen it, and I've worked out a few things about it. So...
with a stick and hit it. Then yes.
I guess if the Earth is accelerating well, the acceleration would be very minuscule.
Yes.
So we'd have to have very accurate devices to detect the acceleration. Therefore,
because it doesn't suit your narrative.
But if...
Okay, now we're up to speed. Excuse me.
That's old logo.
Yeah, it's old intro. Does it spin? Does it spin?
How much Star Wars?
If you answered yes, you have a problem.
Oh no.
I will bring up a video.
Oh yes, I can.
About a guy named... Who's the guy? Luke Akins! Do you guys remember Luke Akins?
I don't.
Did a world record back in 2016 jumping without a parachute. Remember that guy? 25,000 feet.
Oh, yeah.
And landed on a net. 25,000 feet off the ground. No parachute. That's insane. Look at that net. That's when he landed.
Wow.
You guys aren't accelerating anymore, just to let you know.
Okay, this guy jumps from an airplane without a parachute for a stunt to see if he can do it and to land on a net. Here's the thing. Flatzoid, and then we'll start going on how the guy didn't have any forward momentum with the plane. He does. And the thing is the plane and him and everything within around that's going around the Earth is within the same gravitational field, but it has the momentum of the Earth. So relative to the ground, well, relative to the ground, he has momentum from being in the airplane, but he doesn't have to the grounds. This is like one of their arguments is a helicopter will take off straight up and hover there, and they all think that the Earth underneath should be spinning away from the helicopter. But the thing is since they're both have the same momentum, they're traveling together. But this guy has the momentum of the Earth plus the momentum of the airplane. And just a second, and actually there's a couple of simple math things here, and they don't like, flat earthers don't like math. If it has anything to do with math, they say, well, that's just math, it has nothing to do with physics. What the? Okay, I'm gonna go to the webcam here to do show a little equation. And okay, webcam. A little diagram of what. Okay. So you have the guy on the plane, he jumps, there's a bit of an arc. In the video that says it's 25,000 feet. Convert that to meters. And then you use these simple formulas. And you notice there's a G, which stands for the acceleration due to gravity. and times squared. And since he doesn't have any velocity in the y direction at first, it's 0, and then minus because it's going down to the Earth. And I messed up there converting. Okay, I looked up at the flight speed is 160 kilometers an hour approximately. That's the general speed that they use, and holy cows. And eventually you get 44 kilometers a second. And then you can figure out how far the net is, which is about 1.7 kilometers. Yeah, this is not coming out that good. Sorry. But before they do, but they have to do this calculation so they can put the net in the right spot. Now let's go back to Flatzoid. Maybe YouTube's having a bit of a problem. Craig was noticing some lag and issues. Or maybe I have a bunch of things open that shouldn't be open all at the same time. The spot underneath the Earth wouldn't boom that much, but he is moving. But they claim that he's not moving, that the plane didn't, but it did. So, yep. You can't tell if he's got momentum from the plane or not because they're not showing the plane; they're just showing where the net is. Okay, I didn't catch Velcro error. Maybe I shouldn't have it sped up so much. Oh, this is back to the beginning.
like I said, everyday kind of like there's an observation that shows do not be a moving nose. Right. Kind of like you think. That's quite a thing. So since you claim Valkyr in, you can show us Valkyr in.
Okay, so maybe in 2 minutes, full I think the Earth rotation would slightly, yes, the Earth rotation would probably be off by.
Let me see. 2 minutes is 2 divided by 60 times by 15 degrees an hour. So 0.5 of a degree. Okay. They tried to calculate how fast the Earth was supposed to be. It's like 820 kilometers an hour. And then they bring up, what was it, the guy who jumped from, what is it, Felix Spot? Can't pronounce it. He died a couple of weeks ago.
How long was he in the air? Pretty high up. 220,000 years, correct?
Plus 5 minutes, maybe.
Let's see how.
How far the Earth would move beneath his feet? He would need to correct all the time, like catching up with the Earth.
4 minutes 20 seconds. 4 minutes and 20 seconds. But the question I want to ask you that's very important though, you know? Is there any air up there now where you were standing?
Wait for it.
But see that bar is the acceleration on, right? Then stop it, you drove it out of here, and let it run straight.
I think we missed something there. I think.
You would agree with that, Victor? Because controlling momentum of the plane, you would have carried on moving with the plane.
Sorry for all this jumping around. Try and not have to put up with much of their conversation.
You remember Felix Baumgartner?
Felix Baumgartner. Gamma.
Yeah. How long was he in the air?
I can't pronounce anything, so.
220,000 years, correct?
Plus 5 minutes, maybe.
Let's see how long.
How far the Earth would move beneath his feet? He would need to correct all the time, like catching up with the Earth.
4 minutes 20.
Well, the thing is he's got momentum of the Earth with him, so he doesn't have to catch up to the Earth. But it's something they don't understand much.
4 minutes and 20 seconds. But the question I want to ask you that's very important though, you know? Is there any air up there now where you were standing?
Oh. Where is it? Sorry.
But see that bar is like acceleration on, right? Then stop it, you drove it out of here, and let it run
How is this happening? Okay, I was trying to figure out something here.
This one is even more damning than that. And you're gonna love this one.
This is probably the most messed up live stream, but
Look at official data. So now, why the fuck is the flags?
Claim two more things. The claim already has information on the mountain of CFL. How can you guys include it here and the arrow speed of 2 people? Yeah? How? That makes no sense.
California. In Simi Valley, California.
You don't think that they could, like, plan that from ahead of time?
Decide about the rain. Tell the earth to stop moving.
No, I mean, don't put it in plan.
Do you remember Phoenix Tom Gardner?
Put the wet balls out.
Yeah. How long was he in the air?
Pretty high up, I'm guessing.
220,000 years ago, right?
At least what, 5 minutes, maybe.
Let's see how long.
okay. I thought this segment lasted a bit. It'll keep rolling because it's under gravity's accelerating it downwards. But if you try to get it to go uphill, it will stop.
Have you ever, for instance, slipped? Let's say you're moving forward and you fell on your butt. And you just carry on moving. You eventually stop.
Yeah.
Because there's something called friction. Even ice has a little bit of friction that eventually uses up the energy in heat. Like when people actually skate on ice, they're not cutting into the ice. They're creating a little layer of water that creates that you glide on. So, and then that's the heat, and you're constantly using energy to keep moving. I'm actually one of the few Canadians that doesn't know how to skate. I'm just a nervous person, so I ended up flailing all over the place. But I have slipped on the ice, and well, played hockey with my boots on sheets of ice in the neighborhood. So yeah, well, yeah, Canadians know a little bit about ice.
So you used up the momentum. The conservation of momentum was there when you fell, but you used up the energy, and therefore you're not going to move indefinitely. You will eventually stop.
Yeah, but in space and there's nothing there to push against you, and within the Earth, the Earth is constantly spinning, so you're constantly spinning with the Earth.
This is the problem you globers have. You want to throw away physics, but want to only use half of the physics for your explanation. Right.
Well, here's an example of using momentum when there's zero things pushing against you. You can go very, very far. Voyager 1 and 2. Okay, let's see if I can. So see, these are the Voyager spacecraft. They've actually gone outside the solar system. And if you know how to use momentum and energy properly, you can take two little spacecraft and put a little bit of energy into them at the beginning and use a little bit of navigational thrusters and use the gravitational attraction between the planet and the planet and the spacecraft and accelerate them out into deep space. They're actually right now they're actually further out. They're in the helipause. The helipause, or past the helipause. The helipause is where the solar wind from the sun and the background gas. It's where the solar wind has no more push against the background gas. But this is what happened. So this is when you can use momentum and gravity together. But they don't believe space is real. So a lot of flat earthers. So okay, let's see what else they say. And we'll find something else to. Not me.
Yeah, it's very simple. You guys can evoke your own conservation momentum, but that conservation of momentum is only short lived. It's not indefinite. You guys require it to be indefinite. You know how long Felix Baumgartner was up there in his balloon?
Yeah, that would be my next question.
2 hours.
And how would it transfer the energy if there's no medium for transport to? So how would you conserve momentum if that might be correct?
Because it's due to the curvature of space-time or particles being transmitted between each other. Nobody's finally figured out the final details. Okay. But they think the air is what's transferring momentum. Well, let's just give them.
Luca, you cannot explain it in a world that doesn't happen. It's impossible to explain.
Momentum is always yeah. But like it's about the whole system, right? It's that below about
But anyway, you guys claim gravity is pulling the skydiver down.
Yeah.
With Kristen's help, Lift.platform can not just respond to customer needs, but anticipate them. So for employees, that means they always know the next best action.
So is that overcoming the momentum now at a different vector?
What do you mean?
Well, just like ballistics. Just like ballistics. It's the same with ballistics. If you shoot a bullet, does it stay in the air forever? Or does it drop due to the force?
It drops to the force of gravity over time. I think I just showed something similar to that. But well, we're going to let them go a little bit longer.
And there's a momentum
would it work it the way that? But basically, that's your orbit flip.
We're not talking about orbits now. We're not talking about fantasy. We're talking about physics. If you shoot a gun, take a gun and you shoot the bullets, will that bullet eventually stop moving?
Yeah.
It will eventually hit the ground unless it has enough kinetic energy to go into orbit. That's what physics says.
Right. So it didn't have conservation of momentum.
It always has conservation.
And then it stopped moving. So it used the energy.
It still has conservation.
If you fire a gun in space, it will keep going. I just showed the Voyagers. They put a lot of momentum and energy into it, and they just kept going. And they used the gravitational force around planets. They'll take several orbits around, and they can put more energy, make the craft go faster. Here's one thing about flat earthers: they don't seem to understand the pointlessness of waiting to talk to people. And they do this during debates. They'll try to overtalk people and yell and scream over people while you're trying to talk to them. And then here they go trying to overtalk each other.
It's about the whole system, not just like the I think as an example, right? Like when you send fossil fuel or whatever the source, right? You have all of these movements, but like the ice and you on the ice plate, right? You're not enough for example when it's floating in space. So the ice is attached to the air a kinetic force, a friction, it will be a kinetic friction force acts between like your body and the surface, and that friction force transfers momentum from you to the right, to the ice system. I suppose you could say that the wing is the same system. So yes, the wing, the Earth ice system was. So yeah.
Okay. Do you believe, Ruka? What did I want to ask you? I wanted to ask something very specific. I want you to say. Okay, let me try and explain. Let's take ground. The ground, and we're just gonna put a target. Okay. Yeah. And now you're gonna have someone pointing a rifle at the target. Okay. And they're going to shoot. That's gonna go. It doesn't go like that. Let's say the target was 100 meters away.
For short distances, yes, and it depends on how much gunpowder there is in the bullet, because that gives you more energy. But depending on the bullet type and the amount of gunpowder in it, it could probably go 100 meters. But a lot of guns probably wouldn't go that far. Probably have a specialized rifle, but.
Would you agree the bullet would impact the target?
would be a bit closer before y'all take effect.
Okay. 100 meters to give you a range. It's a Canadian football field, and the field length. A Canadian football is about an extra 10 yards to an American football field. So it'd be quite a bit long. So it'd be quite the shot.
Let's make this 1,000 meters. Will it still reach exactly the same point?
No, because by then, I think the furthest. See how far. Let me just check something. I don't think any rifle's gone on a kilometer. AI junk. Okay, probably not easily found, but by then gravity would be probably taking over and the bullet would be bloop. I don't think it would make it to a full kilometer.
If you're just pointing vertical, or if you're just pointing horizontal.
No.
Why? What happened? It dropped. Why is that? Why is that?
Well, one, she's losing energy.
Yes. So is it conserving the momentum indefinitely, or is it losing energy because it is transforming that conserved energy?
It's being pulled by gravity.
In other words, your conservation of energy argument falls short in physics. You cannot indefinitely conserve energy.
Because it's trying to fight against gravity. Because what's happening to the bullet is its forward kinetic energy is changed into gravitational energy, because the gravity of the Earth is more than what the force of the bullet in that direction.
And I want to point out something. In a vacuum too, something loses energy too. Conservation doesn't stay even in a vacuum.
Conservation in the vacuum, there's hardly any air to resist it, and there's, depending on how close it is to a gravitational field, there wouldn't be any effect from another force. You need you need a force to change the momentum, like a big planet.
you're driving a car 60 kilometers an hour and you jump out of that car, are you still going to fall forward at 60 kilometers an hour? No.
Yes, you will, because you'll go forward and then the gravity will kick in and, well, not kick in, but you'll take over and you'll fall down in a parabola or half a parabola. Now things, they think air is what's transferring momentum from one object to another, and it's just not. That's not how it works. It's just how physics works. An object will stay in motion unless an external force acts upon it. That's momentum. And the external, and if you're hovering above a planet, you're there's no force moving you, so you're just going to stay in the same spot above the planet, because both of you guys have the same momentum until you jump out, and then your momentum's changed into kinetic energy going on the way down.
And when he jumped out his plane, out his balloon, he was still defying his conservation momentum.
What do you mean the conservation momentum doesn't apply yet? Why do you say that? Why do you?
Yeah, you just said that. Because he was moving with the Earth. Plus, they've figured it out with calculations where their target would be. Now I remember what the Velcro air is. Well, flat earthers think since there is no barrier between the Earth and space, that the atmosphere would just magically disappear into space. But the thing is gravity affects the molecules in the air and keeps them close. The air molecule has to travel faster than 11.2 kilometers a second to escape the Earth, and that's the escape velocity. And most molecules don't have that kind of energy, and it's usually light stuff like hydrogen and helium that has enough energy to escape the Earth. So that's what. So they think, since we think that the air stays with the Earth and keeps moving with the Earth, and it's the thing with the movement with the Earth, you get the Coriolis effect and you get other little eddies and currents in the air. It's not velcroed to it's part of the Earth. It's the gravitational force keeps it to the Earth. So that's what they meant by velcro air.
It's a yes or no question. Do you believe that the velcroed air is moving with the Earth, but everything in that velcroed air is moved because the air is pushing it?
Okay, things aren't moving in the, well, okay, the air is not velcroed, and the air can push things around like kites and balloons and blimps and stuff like that. But for airplanes and stuff like that, they actually most of the time have to overcome the movement of the air to move. But I think I'm going to move on to something else in a few minutes.
Sort of like if you climb in a river that's moving. You can swim, but you're moving with the current of the river.
You're moving with the current of the water, so you get fine compared to against. So, like that,
yeah, we're still going to get to that. I'm just trying to quickly get him onto Phoenix Lombard.
Well, if you're going this way, that's with the motion of the Earth. You still have air going that way. And then when you go this way, so you get a headwind, and then when you go in this way, you're moving with the wind, and you get a tailwind, depending on which hemisphere you're in. Okay. So when Baumgartner's up there, he's up here, and he's still moving with the Earth, because the conservation of momentum, and he keeps moving. So this is just them not understanding that you can have a motion this way, a motion this way, and a motion this way, and adding them all up.
Because he doesn't understand that if you're claiming the conservation of momentum is moving because Velcro air is moving with the Earth, everything inside there is moving because that Velcro air. If there's no way to move it, you can't claim conservation of momentum. Yeah. It's like trying to say you're swimming in a river without water.
So you're saying that the conservation would make it immense without it?
Sure. I'm not only the definition of if the Earth is glowing, if the air is moving, if the Earth is moving, below its feet, because there is no Velcro air where it is, because it's nearly vacuum to play. So
Was this the one I did a couple days ago?
you're missing this point because Earth should be moving below his feet. The point is how it's possible he got them to the point and he landed. How it's possible though, when the Earth is at normal speed. Get it right.
Well, that's not a spaceship, right? Or some kind of thing, obviously, because he had to wait. So, the mass, the suit, and him would weigh something, and I guess his temperament or state would more likely be, I'm not sure,
we lost track of the big time, we can't explain it. You see how ridiculous it is, they're trying to explain. You can't comprehend what they're trying to say.
but like, with the atmosphere being within the freedom of atmosphere or whatever it is, stratosphere, yeah, like atmosphere will add to that wind, so the drag will be very small, like the pressure.
Even if it will be very small, such distance, such height, it will make huge difference because of the height.
Like for those few seconds, or maybe I don't know, was it now? The first few seconds of his fall, the downward momentum nearly zero. I guess.
Believe me, this.
Okay, I'm gonna find something else. I'm getting a bit tired of their voices. Okay. Okay. Let's see. Let's see what if Mikey Smith has published anything lately. I know he went. Nah, nothing really new. Well, he took this picture of Venus. He thinks it's Venus. Nobody can tell if it's really Venus or not. Actually, somebody did. Curious UK Debunks did a better discussion of this. So let's find something. Level Earth Observer. Doesn't like being called the Flat Earther, but. Okay, this looks.
NASA administrator will line around chapter space shuttle. Now this is a map. The name on magnetite is a very rare photo. From Challenger space shuttle 9 months before it blew up. Like I said, there was a NASA administrator who at the time was an astronaut. The guy name is Frederick Gregory. Frederick, like I said, went on from NASA astronaut to administrator of NASA. Problem is, the footage we're going to see where Frederick's narrating his first ever journey in the space shuttle, where he was a rookie pilot. He said, the problem is, the narration gives the game away big time. So this is the quick question. Like I said, Frederick's going to be late.
I think I've seen this.
The clip's about 3 minutes long, so I'm not going to stop it. I'm going to come in at the end. So this is the ideal opportunity for you guys to watch this and see if you can spot the problems yourself. I'm coming at the end, and I'll highlight it and see if you can spot.
Oh, I remember this one. I think I actually did this one. So, oh, check CC. Thing is, it's kind of summertime, so everybody's busy. Plus, the thing is, flat earthers can make up things a lot faster than we can. Okay, we'll see what the CC has to say. Probably will go into politics, knowing CC. Oh, CC's favorite number, 33. How long was it? Yeah. I know I'm going through things. I think I'll actually shut it down because I don't really have much to talk about tonight. So, I just did it at the last minute to get some practice in, and because Craig was out and probably some people wanted to watch something. But I hope everybody has a good night and goodbye, and hopefully there's something else going on. Bye.